Hi, good morning or good afternoon, everyone. Can you open your video so that we can have a better communication? Today we will discuss about regression, right? And then if we finish this, we will discuss about dimensional reduction through PCA, principal component analysis. So before that, I want you to check in Google Classroom. Okay, so I posted there about scikit-learn. Okay, so can you see? I will share my screen. So for your project, you can create program using Python. Okay, this is one alternative. So if you use Python, this is my suggestion to you. Okay. First, you download Anaconda. So click this one. Okay. So Anaconda is a kind of a way to bundle Python, okay, with other software together. For example, with Spider, okay, and Jupyter Notebook, okay, together. And if you download this, yeah, and you install, okay, the installation takes probably a few minutes to 1 hour, depending on your laptop or your computer. If you install the Anaconda, you will have this menu, okay, Anaconda. So 3 things I want you to see. Okay? Number 1 is Anaconda prompt. So when you click this, you will get an Anaconda prompt, something like this. Can you see it? This is where you will install other program inside Anaconda. Okay. And second, you will have in Anaconda, you will have Jupyter Notebook. Okay. What is Jupyter Notebook? Is so if you open this Jupyter Notebook, you will have something like this. So Jupyter. Okay. And then you can create a new Python 3. So now you have a Jupyter Notebook. This is a notebook. Okay. What is this? This is a notebook where you can type. So I can type, for example, this is my text. Okay. So this is my text. Right. And then when I press Shift Enter, I will get a text. But I can also do running any program here, a Python program. Yeah. For example, print hello. Right. So and then Shift Enter, I will get hello. Okay. I can also do calculator here. 1 plus 2 plus 3. Okay. Yeah, I can get directly then. So this is the text that you can do a documentation, okay? And you can also run the Python program directly here. And when you finish, you can save it. You can download as HTML, LaTeX, Markdown, PDF, or Python code itself, or HTML if you want. Okay. The third things I want you to see is Spider. So in Anaconda, okay, there is another program called Spider, where you can run Python code here. So There. You can run a Python code. This is example of me. I'm making the code. So, and then the result will be on the right side. Okay, so this one, I create a class, cat, dog, and sound. Okay, so kitty is a cat, buddy is a dog. So, and then I print kitty sound meow and buddy sound bark. So when I run this, I just run with this run file. Okay, and the nice thing about the spider is I can now debug. Okay, so I can put here my code, click here. So you see the red button here, the red color here, circle, and then I can debug. Okay, so when I debug this, there it will run up to this breakpoint, and then I can check the variables inside. You see that? So the variable inside this I can check, and then I can know what is the actual size, the value, and so on. Okay, so up to here, any question? So first thing first, you need to install Python, or that is through the Anaconda. That is my suggestion. Of course, you can download Python directly, okay? But you will get only idle. Idle is the name of the IDE of Python. Okay? But if you use Anaconda, you will get a much better result. This is my suggestion. Second, okay, for those who are keen for AI and data mining, so here it is. Okay, if you can download later the scikit-learn. I think the scikit-learn is already inside the Anaconda. If not, you can just download here in GitHub. So what you can do using scikit-learn, all the things that we will learn in this class is already here. So you don't need to code it anymore. The code is already here. And you can read your own, the documentation of it. Can you see it or not? So you have classification here, you have regression, clustering, okay, dimensional reduction, model selection, pre-processing, everything is here. Okay, and all you need to do is just copy and paste the code. Okay, so for example, in SPM, right? So there is a code here that you can just copy and paste. I will just copy and paste here. For example, I copy and paste in Jupyter. Okay, so I copy and paste to Jupyter, and then there. Here I have x equal 0 and 1, so I copy and paste here, right? And then y is 0 and 1. And again, I copy and paste per line. If you want, if you don't want, you can copy all. And then this one, again, you copy and paste. And this is to fit, meaning to calibrate. This is called learning, right? And then you can do a prediction. Yeah. The result is 1. My screen is off. Oh no, what happened? Can you see? So you download from this is the spider. Okay. So can you open your video, please, so that we can communicate better? I don't like to talk to the wall. Can you open your video, please? Thank you. Okay. And if if you think I missed something, so you tell me, you give me feedback, okay? So uh, my suggestion to you is to download Anaconda, okay, then install it. It's free. Okay, number one. Number two, I also suggest that you download Weka. Okay, so if you go to a Google Classroom, I also posted there in dimensional reduction Weka. Can you see? There in Google Classroom, there's Weka download. Okay, and you can download Weka. What is Weka? Right? So Weka is another program. Huh? So this is the program from the University of Waikato in New Zealand. So you can download. So for my case, I use Windows, so I download here. If you use Mac OS, you can download here. If you use Linux, you can download it here. Okay. So once you download this and install, you will have this kind of Weka, this program. Okay. So it's very easy to use. This is just this is all you need to see only the first with this Explorer. So Weka Explorer. So you can get the file. The file is in I think in program file maybe Weka. Or program file 86 Weka. No, not here. Where is it? Program file. There. Weka. Yeah. Okay, and then go to the data. So these are the example of data that we have in Weka. So this is iris example. So you just open it. There you can get the iris data open. Okay, and then you can classify, you can do clustering, association, and visualization. See? Okay, and you can do pre-processing. So you can choose what filter you want to do. For example, you want to do discretize, for example, you can just select. And you can do resampling, for example. Okay. Once you do a resampling, you apply, then you do resampling. Okay. In classification here, for example, you want to do what? Neural network here. Okay, neural network is multi-layer perceptron, the name. Okay, so what you will do, you just start. There you get the neural network result. See, and this is the classification result. Okay, all you need to see is only the how many percentage correctly classified, 95%. Okay, so there is a program that you can use easily. If you just talk about, oh, how I will use programming, in this case, you just use Weka. If you don't like programming, if you want programming for your own, Weka cannot do, then you can use Python. Yeah, scikit-learn is pretty good. Okay, and what we will discuss in the class is actually much beyond that programming, meaning that programming is rather simple. All you need to do is just copy and paste, isn't it? Right? So I don't teach you how to copy and paste because you can do it on your own, right? But I will teach you the background so that you can read, so that you can learn by yourself eventually, right? That is more important for me to give you some foundation. Okay, that's why I give you the mathematics behind. You understand? Okay, so I give you why the program works that way. So with the mathematics behind, you can actually create your own program. You can also extend it. for your own application that you want. Something that the people provided did not provide, you can go beyond. Do you understand the education philosophy here that I'm trying to give you? So I give you the background, okay? I give you the mathematics behind, but I don't teach you the programming, because the programming is rather simple, because all you need to do is just copy and paste, isn't it? Is that okay? But if you really want me to teach you programming, I can do, no problem. That's super simple. Okay. So up to here, is there any question, comment? So with this, you can do the project, okay? So you can use Weka, you can use scikit-learn. Okay. And if you have any question, of course, you can approach me anytime. Yeah. Not only during the class, that's okay. Right? Okay, so now let's go to the real lesson of today is regression. Okay, last time we discussed a simple linear regression, right? So I hope you remember that. So the last time we discussed was, and then we discussed nonlinear regression. Finish, right? Oh, the last part is the matrix. Okay, let's do this. First is the motivation. Yeah? Why I give you the matrix? Okay. Because using this matrix, okay, you practically can do many different type of regression using one simple formula. It's A times B equal Y. Okay. So all you need to do is you have say, suppose, okay, the simplest model is a simple linear regression, something like this, right? So y equal mx plus c, right? So if we list down this model into for its data, say our data is x1, x2 until xn, and y1 until yn. Okay, so for each row of the data, you have m times x1 plus c equal y1. M times x2 plus c equal y2 and so on, until m times xn, that is the row number n, plus c equal yn, right? Then you can put all of this into a matrix form. This is important. Your data should be put into matrix form. How you will put the data into matrix form depending on your model. Okay, so if your model is a linear model like this, what you have, this is m times x plus c times 1, right? M times x plus c times 1. So that's why you have x and 1 here. Okay, and then each row will be multiplied by its column. Yeah, so I will put this. So you will have this row multiplied by that column will produce this number, which is y1. And then you will have second row multiplied again by this vector mc, you will get the second row. Okay, with this level. Okay, is it clear or not? This matrix representation.
Yes.
Yes, thank you. So next is once you put into matrix representation, okay, so now you have matrix A, let's call this matrix A, and then your parameter is matrix vector B, which is consists of M and C, and then you have your data again, which is Y, okay, Y1 until Yn, right? The X here is actually X1 to Xn, right? So then what we have what is called a system with equation, yeah? A times B equal Y, okay? How to solve this is using generalized inverse, okay? So how to do generalized inverse? Why we need to use generalized inverse rather than inverse? Inverse matrix happen to only when your matrix is actually square matrix, isn't it? But your data matrix is not square, okay? It's rectangular, meaning usually your data is long like this. So if your data is long to the bottom, okay, you have more data than the number of variables, isn't it? Right? So in that case, we use what is called generalized left inverse. Okay? Now, if your data, okay, if rectangular something like this, meaning your number of variables is more than your number of data, yeah, the row is less than the column. In that case, you will use generalized right inverse. Okay, but this is very rare. Okay, so mostly you will use generalized left inverse. So how to get generalized left inverse is first you have A times B equal Y, right? So then I multiply by transpose here, right? After that, I just put parentheses, and then I multiply by the inverse, hoping that this inverse exists. Yeah? And what happened is this one times this one is inverse time itself is basically identity matrix. So then we have this is the generalized left inverse. This is the L. Okay. So this is the L, which is called generalized left inverse. Then how to get B? B is what? M and C a while ago, right? So it's just multiplication of L and Y. Okay, so look at this. You can use the same formula with the generalized inverse for doing simple linear regression, something like this, right? You can also use the same formula, okay, for multiple linear regression, something like this. And then you can also use the same formula, A times B equal Y, for polynomial regression. Also for regression for classification as well. Wow, right? So the same formula you can use for any kind of regression. Okay, so did you practice this last time?
I think so.
You think?
I think so, sir.
Yeah. Okay. Good. Thank you. So you have this data X and Y, right? And then you put the X into a matrix A, right? And then you get the transpose of A, right? And then what you get? You multiply the A transpose with A, right? After that, you get the inverse of that. And then you get the generalized inverse, yeah? The generalized left inverse. And then because you know the population here is Y, then you get the B, okay? B is what? B is just L times Y, right? Okay, so now I want you to practice. Today I want you to practice this. So this is the data from a second-hand car. of the same type of car. So let's do what is called multiple linear regression. Okay, so the input will be age and kilometer. So how many months and how many kilometers. And this is the price. This is second hand. So you can multiply by 1,000 or I don't know, any price. So the question is, yeah, can you do it using matrix? Okay. So in here, our model is what? A plus B, right? Our A plus B times 8 plus C times kilometer. So that means A times 1. Yeah? In A, yeah, you times with 1. So that's why we have this matrix. A times 1, and then this is the number of month, right? And this is the kilometer. Okay. And the dependent is the price. Yeah. Then how you solve it? Yeah, the same. You use the same method. Okay. Once you finish, you tell me. Okay. You show me the result. So this is the result. Supposed to be. Okay. And after you get the result, can you get this error? The estimate and the error. Okay. So I need several person to recite today. So first is to get this, the one who get the result of the parameter first, okay, we'll get the recitation. Second is to get the forecasting. Yeah, forecasting of this. Number one is forecasting of the price. Okay, given the age is 21 months and then almost 15,000 kilometers. Show me in Excel. Okay. Now, 2%. And if you have a problem, you tell me so that I can help you. Okay. can I expect that you have downloaded Weka by next week? And Anaconda also?
We actually have Anaconda already, sir, I think.
Oh, you already have.
Yeah, from previous studies, semester
Oh, okay,
4.
so you already have it.
Yeah.
Okay.
Yes.
Then you can open your maybe Jupyter or your Spider, and then you can also do the same. Yeah?
Yeah.
Instead of using Excel, you can also use the NumPy and then compute this exactly the same generalized input using NumPy. Can you do it?
Yeah, sure. Okay.
Hmm.
So
Or if you really want to copy and paste, you go to scikit-learn and regression. You can also do that.
mm, okay.
Hmm. It's good. I I have learned that you actually have a Python class before. Is that correct?
It's the I forgot the name of the cluster, but yeah, we did. Uh-huh.
That's good.
But I think personally it's the learning process is kind of uh like it's it's kind of forced, so
Hmm?
it's not really optimal, sir. So like I mean, so the first exam is like the midterm is like basic, right? But the
Okay.
final is kind of like the difficulty difference level is kind of steep.
Hmm? Explain more detail. I don't get it.
As in like for example in the midterm, right? It's just mostly basic programming, right? But
Programming mean looping, if then,
yeah, something like that.
right?
Combining with orange and something like that.
Hmm.
But the final is more like a like regression and all of that supervised and unsupervised learning stuff
So
with
you
a
already
with
learned that.
with a real case. So like the level of difficulty is kind of different. So it's like because the time of the semester is short, right? And there is so much to learn. So yeah, uh-huh. It's not really optimal, I think.
Okay. So anyway, if you want, I have I have a tutorial. Okay, in Revolut 2. There. The first one is Python. There. So I have several tutorial on Python using Jupyter. Okay, this is usually I give. So if you are not sure about what is Python, NumPy, Pandas, and so on, so you can start to browse these pages. So learning Python, for example, you will learn the basic like 1, 2, 3 output. Okay, all you need to do is just copy and paste this code in Jupyter and do exactly the same. Right? I think you have learned all of this anyway. So in Python, you need to know all these basic of flow, if then looping, right? And then the collection of the object like list, tuple, dictionary, and set. These are the basic. Okay. Once you know how to do all of this basic stuff, okay, you will learn about a function, and then learn about class, how to define a class, and so on. So inheritance and so on. So once you have this, it's finished. That means you know how to do Python. The rest of the Python, what you need to do is just, for example, data analysis, okay, or using NumPy. So using the library, using scikit-learn, for example, SPM in here, right, or regression. Okay, so you can say this is the data. You can just copy and paste. You can create the data on your own, and then do all the stuff in Python. Say if you are not familiar with NumPy, so you can read this as well, or Pandas. Pandas is also important. So I think if Pandas is like database, but or combination between database and Excel, so you can also learn this. Okay, you just read and then copy and paste. That's it. If you are not familiar.
If you're using Python, can we just use Google Colab? I mean, what does Anaconda have that Colab doesn't? Google Colab.
I cannot hear you. What do you say?
If we're using Python, can we just use Google Colab? I mean, what does Anaconda have that Colab doesn't?
Hold on. Can you type what?
Okay, sure.
Google Colab. Okay. Yes, you can.
Okay.
Okay. You can use. You don't really need to use Python. If you don't like, you can use MATLAB. You can use C or Java. It's up to you. Okay. In this class, you have a freedom to use anything that you want. Say you don't like programming at all. You want to use Weka only. Yeah, you can use Weka. Why not? Say you don't like use Weka. You want to use Excel. That's also okay. Right? Good. As long as you can do it. So in the class, mostly I use Excel, right? Mostly. Why? Because Excel is like the simplest thing that we can use for education. Okay. But of course, you can choose your own programming language. Including everything that you want for different framework like Google Colab and so on. Okay, so have you done the simple linear regression a while ago? Anyone can share screen?
Maybe I can share for the
Yeah,
error
cool.
here.
Yeah,
Okay.
cool.
This one. I think I only done the error.
Very good, very good. Yes. So you get the intercept and the eighths and the kilometer, right? The ABC here.
Yes.
Okay. Now tell me, Shannon, what is the meaning of that A there? The intercept.
Oh, this, I think it's the price of the new car from the first
Correct.
time they bought it from the car dealer.
Yes, correct. So that price of new car, why? Because when you put kilometer is 0 and 8 is 0, that is the price of new car, right? So what is the meaning of B and C in that case?
I think the B is after you use the car, and then it will be times the months you use.
That is the reduction.
Yes.
That is the slope, okay, of the month and the slope of kilometer. Okay, every month that you use, it will reduce that much. The price.
Okay. Okay.
The unit.
Stop sharing.
Very good, very good. Okay. Now, I will share the. Yeah. So if you look at the result here, okay, this is the model, right? Based on the unit, okay. So you can actually get the unit of others, okay, of A, B, and C, okay. Price is in, say, in US dollar. A, we don't know. B, we don't know. The eighth, if the unit is month. C, we don't know. And then the mileage is in kilometer. Okay. So if you put the eighth and the mileage is 0, that means you have new car, right? Then the price equal A. In that case, the unit of A will be in US dollar. Okay. If you put now X2 is 0, right? In this case, the 8. Yeah. If you put X2 is 0, the mileage is 0, then you have what? The price equal A plus B times 8, but A is already in US dollar. Huh? That means B, now you can put as US dollar per month. The same thing, if you put X1, which is the 8 is 0, then you can put C is in US dollar per kilometer. Huh? Then you can check the unit must be correct. Okay. So B and C in here is the gradient or the margin or the slope, yeah, of the price by the age and the mileage. And now, if you look at the equation again, okay, all is in positive, right? A plus B times 8 plus C times kilometer. But the result is actually negative, correct? The result is actually negative. So in that case, you know the result is correct. Why? Yeah. Negative 24, negative 20 in this case. Yeah. So the result is correct. Why? Because, of course, when you use, the price will reduce, right? So based on the meaning, okay, you will know whether the sign is correct or not. Okay. Next. Now, we want to know, okay, what is the range of this value of A and B and C, right? So the more you say it, the price will go down. You know that A must be positive because this is the price of new car. The sign of B must be negative, and the sign of C must be negative also, right? So then you can assume, okay, how to get the range, you can assume. So assume that the used car have no more value after 15 years. So 15 years is 180 months, or after 5 million kilometers. So this is the extreme value, right? So then you can put it into the equation, right? Okay, to get the value of B and C, okay, in terms of A. So now you get the relationship between A and B, and then A and C. Okay, since you know the price of a new car, right? Then you can easily calibrate what is the value of B and C. This is the range of B and C in this case. Okay. Now, if you create a multiple regression like this, okay, this is important. You can calculate, but what you need to do is to interpret, right? Interpretation of the model is the job of human. To calculate is the job of computer, correct? So this is the clue. Okay? This is the clue how to tell that this is actually okay or not. Okay, so look at the t value based on the t-test and the sign. Okay, so if it is correct sign and then based on the t-test is significant, then check. Okay, the t-test is to test its variable, right? So this variable is a policy variable or not. Okay, if this is policy variable, what is the meaning of policy variable? Policy variable is the variable that actually you use for a policy. Yeah, you use for decision making. Okay, so if it is a policy variable and significant, of course you include. And other variable is not policy variable, of course you include, right? If the sign is correct. But if the sign is correct, but the t value is less than, say, 1.6. Okay? Then if it is policy variable, you still include. No? And if it's not policy variable, you will reject this variable. Now, what happens if it is a wrong sign? Right? And if it is a wrong sign, then it is a policy variable, then you have a problem. And it is more problem if it is a wrong sign and the t value telling that it is significant. It's a big problem. Right? So then you probably need to modify your whole model in this case. And if it is wrong sign and this is other variable, then you simply reject it. This is the way to do modeling. Okay, so in multiple linear regression, say you prepare the data, right? So the y is the output, and then you have x1, x2 until xn. What you will do? You will do a list of combination of the model. Okay, so what we expect? We expect between xi, okay, between the independent variable, the correlation is low. Okay, and the correlation between x and y is high. This is what we expect. Okay, and you need to satisfy all these three tests. Okay? What is the test? First is the absolute value of the t value. Okay, for each variable must be larger than 1.645 or 1.96, depending on the significant level. Okay, and the significance of s is f. Yeah? F value must be less than 0.05, and the r square must be larger than 0.6. Okay, this is like the rule of thumb. Of course, the higher is better. Yeah, the best model will be the highest r square. So look at this. The most important part here is actually to get the list of combination of models. So here is an example. Okay, I have a correlation matrix between y and then x1, x2, x3, x4, right? And then I created the combination list of model here. Can you see in the left side here? I have y equal a times x1 and so on until full linear regression. Okay, and then look at it, the correlation matrix, right? So if you look at this, the R square between y and x is less than 0.6 in this top model. So in this case, we cannot use. In this model, sorry. Blue. Okay, in this model, what is this? Between x1 and x3 and between x2 and x4, the correlation is very high, right? Because x2 and x4 is very high, then they should not be in the same equation. Yeah? So if you have x2 and x4 here, then this model must be removed. Yeah? If you have x1 and x3 in the model, this one must be removed. Yeah? This all, the one in red must be removed. Yeah? So finally, what you have only 3 models here to test. Yeah? This one, and this one. Can you see? Okay, so these are the 3 models that you will test using T, F, and R squared. These are the steps. Huh? Any question until here? Is it clear? If you want to use a multiple linear regression, okay, what you will do? You will generate first the list of combination of the model. Okay, and then you check the correlation between X must not have high correlation. Between Y and X must be high correlation. And then you remove. Okay? You remove which model that have high correlation between X. Why? My question is why? Why between X should not have high correlation? What is the meaning of high correlation in this case? Anyone can answer that?
Sorry, can you repeat that?
Can
you repeat your question?
Okay, which part? The linear regression?
No, not the question about the correlation of something.
Oh, okay. My question, why between independent variable must not have the high correlation? What is the meaning of high correlation?
Maybe it's the same variables, so it doesn't really matter if we use both of them, because what matters is only one of them, because I think it's correlated between those 2 variables, right? If
high correlation mean that they are actually the same variable, right? If you look at the equation inside, we use matrix, right? So in the matrix, okay, if you have a high correlation, what will happen is they are actually collinear. Okay, geometrically they are parallel. Okay, geometrically they are parallel or collinear in the same line on the same plane. Okay, so if you use that, if you put into the equation, so it will create what is called linearly dependent. You remember in linear algebra. Okay, it will create what is called linearly dependent. So in that case, they have the same variables. Okay, then as the result of that, your R square will become very high, but actually overfit. Okay, so we try to avoid that overfitting. Okay. Now, so what you need to do is to list the combination and then combination of model, and then you remove all things that are high correlated between independent variable and low correlation between independent and dependent. Yeah. Now, what happens if you have this model with this polynomial regression? What will happen if you use polynomial regression instead of multiple linear regression? Okay, so look at the model here. I'll put red ink here. So look at the model here, right? So then we have, so I will put B plus, not in the, so B plus, B multiplied by 1, so this one, right? And then plus A1 multiplied by X1, this is the X1 vector, and then A2 multiplied by X2 square, okay, up to the last one is AP multiplied by XP exponent P. So in your data, in your matrix, okay, what you will do is for your X, you put, this is the actual X, in here is the X squared, and here is the X exponent P. Okay, and then you will do exactly the same as before. Yeah? So I want you to practice this so that you will understand what I'm talking. Okay, try this. Just 4 points. You can do in Excel, you can do in NumPy, or in MATLAB if you want. It's up to you. Can you try use generalized inverse, okay, to fit this into a simple quadratic form? And these are the 4 points of the data. So what is the matrix in here? The most important is what is the matrix? I want to create a matrix A, and then what is the, let's call this C equal, I will have A1, A2, and B. Yeah. So later on, I will have A times C equal Y. This is the equation that we will solve. Huh? So now, what is A? A would be what? X, X squared, and then 1. Okay. What is X? X will be 1, 3, 4, and 5. What is X squared? What is X squared here?
5,
1, 1, 9,
1,
16,
6.
25.
25. Okay. And then this is 1, 1, 1, 1. Okay. Then you can solve it. Right. The way to solve is exactly the same as before. Huh? So something like this, right? So then you can get the result. Anyone can show that you have done it? Anyone can show?
Maybe I could show it.
Ah, cool.
So this is the, can you see my screen, sir?
Mm-hmm.
So this is the transpose, and then we times it with the A, then we inverse it, and as the L, we times the inverse with, we times the inverse of A transpose times A times by A transpose.
And how do you get the B? The parameter above. Huh?
Yeah.
Okay, very good. So this is the linear regression a while ago, right?
Yeah.
Very good, James.
Okay.
Okay. So is there anyone who to share the quadratic equation? The quadratic equation with only 4 data. Next week, you come early, okay? We will start on time. So if you miss it, you will miss the test, okay? Next week, we will have a simple quiz, only 1 or 2 questions.
What's the quiz about, sir?
Regression.
So Excel, okay.
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 So I hope today we'll finish all regression so that next week you will have the quiz about regression only.
Okay.
Okay. The quiz is only 5 minutes, so if you miss it, you will miss it. So don't be late, okay? This is also good to practice because some of you in the midterm did not get it because because the what is that? For example, have several questions, several answers. You answer only 1 or 2, which is not correct, to come 0. So if you practice a lot this kind of type of question, then you will have no problem during the final exam, right?
Also, it's just gonna look like our midterm. So
Yes,
Google
exactly.
Form.
Yes.
Okay. Okay.
Just like in your midterm, okay? But only 2 questions instead of many. 1 or 2 questions only.
All right.
All right. Just to make sure that you come on time. That's the purpose, and you will study what you will learn. Right. Okay. Can you do a quadratic equation, only 4 points? Because this is only 4 points, can we use inverse instead of generous inverse? No, right? Because we have 3 by 4, so we cannot use inverse. We still need to use a generalized inverse. 3 columns and 4 rows. Right? Anyone can show? In Excel, what you need to do is you will do exactly the same step, but different size, right? But if you use Python, you don't need to do programming again. So all you need to do is just change the data and then run the same code. Because this is in matrix equation, so once you put into matrix, everything is the same, regardless the size of the data. I have here is just 4 by 3, but if you have a million by 3 or million by 100, it doesn't really matter. The equation is still the same. If you run the program, it's the same program. You just change the data, okay? Everything will run smoothly. That is the power of programming. And that's the power of matrix. Because size does not really matter anymore. When you finish, can you share your screen and you can claim your reputation?
Can you check mine?
Yes.
Okay. Hold on. Okay. This one?
This one is, okay, this is the Y.
This one is the X, the X square. And I just transpose it.
Oh, wait. Okay. Which one is the X in here?
This one.
No.
What? It's not?
I mean, which one is the matrix A?
Oh, there's A. Wait, I forgot the equation.
Which one is matrix A? Yeah, this
Oh, matrix A is this one, right? The 1, 3, 4, 5?
no.
No?
No.
But I got the same
You
answer.
go to the next slide. You go to the next slide.
Okay.
Next slide. There. That is the matrix A.
Oh, this one.
Yeah.
The ones.
This matrix A is 4 by 3.
Okay.
Okay. Did you do that also? No?
Yeah.
You
Oh,
did.
okay. Yeah. So that's, yeah, this one's 4/2, right?
Okay. So that one you name it as A underscore.
Okay.
No. Only the number.
Fine. Oh, the number.
Only the numbers you put as A underscore. Yeah,
What do
from
you mean?
A2 until C5. You highlight A2 until C5 until C5. C5. Yes, that one you go to the name box there and then you name it as A underscore. Yes. Underscore. Okay, very good. Enter. Yes.
Oh, oh.
Yes, that is the name, right?
Okay.
Color it differently so that you can know that this is your input data. Okay, and then what you transpose?
This one's. Yeah.
Yeah.
The A underscore.
Yes, that is mean A transpose, not X transpose.
Okay. It was.
Okay, and then okay, you multiply.
So I believe this one's supposed to be
Yeah.
A transpose.
Okay, so and finally you get the result. Very good. Yeah, this is the
Okay.
59 minus 112 and 30. Very good. So, yeah, very good, Nicholas. So, next, yeah, the same using the same program that you want, you created a while ago. Okay. So now let us do this. Okay. You use the same parabolic model. Okay. A x squared plus bx plus c. But now x, your data, x is your data, right? Your data will be random. Okay, you just put random number, random between 1 to 10 or 1, whatever. Okay, and then you, because you already create the program, so you can create the regression value, yeah, A, B, C. Okay, and then what happens if you add noise? So what you will do is like this. If you don't add noise, okay, because you created from the real the data you created from the real model, right? Then it will fit exactly something like this, right? So, and if you so r square will be 1 in this case. So if you add noise, so the blue in this plot is actually the so I will put noise to the x, okay, and we still can use the same polynomial regression here, right? But the r square will be very low. Okay. You remember how to compute the r square, right? So to compute the r square, you calculate the estimate first, y estimate, okay, and then you calculate the square error and then square mean difference, right? Okay, and then r square equal to 1 minus square error divided by square mean difference. Okay, okay, try this. So this is to prove to you, okay, this exercise is to prove to you that adding noise, yeah, will only reduce the r square, but your model will be still the same, yeah, with this in this case polynomial regression. So first you make without noise, okay. After that you add the noise. If you have done previous practice, so you only need to change the X and the Y. Once you finish, you share your screen. Do you understand the point? So in this example, okay, so you create a random X. So if you look at this is a random value. Say I put negative 100 to 100 divided by 10, because you will have a real number here. Okay, between negative 10 to positive 10, right? And then the Y value here is the based on the polynomial. Okay, so this is the A, B, C, which is constant that you put any value that you put. Okay, the one in yellow here is the value that you inputted. Okay, so if I know the A, B, and C, right? So I can, and X is actually any random value, and I calculate the Y, right? From there, I can get the A, the matrix A, and matrix A transpose, and then the general left inverse, and then get the actual value, which is exactly the same, right? Okay. And then I can get the R square. Now I can also add noise. Okay, so how to add noise? Okay. When I add noise, I will add noise to the Y value. Okay. So I will add here a norm inverse of random value with certain mean and certain noise of standard deviation. Can you see the formula?
Yes.
So exactly the same, but now of course if your noise is very low, okay, so again they are close to the actual thing. Yeah? So you can see the R square is become 0.999. Yeah? So this is the noise is 1, right? So mean 0 and standard deviation is 1. So, but if the noise is say larger, 2, for example, or 20, so you will see the larger your noise, standard deviation, so R square will go down. Okay, so if my noise is 100, for example, so it will become 0.1. If your standard deviation is only 10, still 99%, right? The R square. So basically, the R square here represent the amount of noise that create the error, isn't it? So using this simple experiment, yeah, you can understand that what is the meaning of R square, and what is the connection between R square and the noise of the model. Do you got it or you don't?
Yes, sir. I think if the data doesn't have any noise, the R square is 100%
Right.
or 1. It may be overfitting.
No, because this is not overfitting. Why?
Oh.
Why this is not overfitting? Because this is actually fitting, right? Because you have the data, and then exactly you plot exactly that signal. You don't put any, so you are fitting. You're not doing
I see.
you're not doing regression here. You're doing actually interpolation.
Oh. Okay, okay.
Okay, the meaning is you have the x, which is random, and then from there you actually fitting it into a polynomial, right?
Yes,
So there is no overfitting here because you are not doing regression.
I see.
Okay, you just plot exactly the mathematics, which is
Yeah.
x square plus a times x square plus b times x plus c, right? There is no regression, right?
Yeah. What I see here, if we add the noise, the R square will drop
The
significantly.
square will drop, right? So here you will start to see the meaning, okay, of R square, right? Oh, R square is actually is to encounter the noise, right? And try to sift the noise also. For example, the mean is not 0 but 1 or 2. What will happen? Okay. Say standard deviation is very low, but the mean is shifted. What will happen? So again, when you learn something, okay, you don't just learn, oh, I can do it, and then I can compute. That's easy. That's computer job. You are human. You don't do the job of computer, right? Remember, you are learning AI so that you will know how to create AI. You know how to interpret the result, not to do AI itself. Otherwise, you will compete with the machine, and you will surely lose if you compete with the machine, right? So you must be smarter than the machine, correct? Right? Then when you learn, you try to experiment. What's the meaning of this, right? Why? Why is it like this? So you keep questioning yourself, right? When you start to question yourself and then you search the answer over the internet, you start to learn, oh, this is what you learn based on your experience, which machine cannot do. To interpret the meaning is human's job. Okay, so learn something that actually your role as a human, not learn something that computer can do better. You will surely lose if you do like that, correct? So you
Yes, sir.
strategy, okay, in this era. That is probably the most important lesson in learning AI, isn't it? Okay. Don't lose over computer just because they are doing better. You have something more, much more than the computer. Okay. You need to know why and how it does like that. So do a lot of experiment on your own. This is just example of one of the experiment. Okay. So next practice, I want you to do a cubic polynomial. Can you do? So exactly the same as before, okay, as the quadratic. Now you use cubic polynomial. So, so set a cubic model, right? So what is this cubic? Y equal ax cubic plus b times x squared, yeah, plus cx plus d, right? So you will have something like this. X, yeah. Okay. Of course, again, you can calculate the r squared. Okay. If the noise is 1, it fit, right? If the noise is very big, the one in yellow is the one that you can change. The rest is just computation. So, what will happen if A is -1? Then the result is totally reversed, right? Yeah. Yeah. So in this case, if you compute the matrix of the regression, yeah, this is to get the estimate, right? So then this one is x3. Okay, this is x exponent 3, exponent 2, and then this is x, and this is 1. Okay. This is x exponent 3. This is x, and this is exponent 3. So the crucial part is to compute the regression is actually to create the matrix A. Okay. That is the crucial part then. So the model is exactly the same. A times B equal Y, that's it, right? What make it different is actually how you input in A, correct? Now try to do the cubic, okay, with the random. And once you finish, you share your screen. So next week we will discuss about PCA. We cannot use Excel unless you create a program of SVD, because but we can use Weka or we can use Python. Okay. So I hope you can download Weka already by next week. In Python, of course, we can use if you have already Anaconda. Anyone can share the screen? Anyone have done it for Cubic? Anyone? Oh, there was a offer to do a hybrid. Do anyone of you want to do a offline class instead of online?
When, sir?
No, I'm asking.
Well, I mean, I think I would, but depends.
So which one is better, offline or online for you?
Mm, cost-wise online, but I don't know, but I don't know. I feel like too much online, it kind of make yourself kind of lazy. I don't know. I feel like I'm bored in a sense.
So
Maybe I'd like to try offline, sir.
oh, so how, depends on the number of students that you want. If only one, of course, I will not go. But
Yeah.
if at least you have half of you, okay, so you have what is that, 14, so 7 want to do online, then we can have a hybrid in the classroom. The rest is taking just using the video, but the video will be totally different from here because the video will be from the classroom, not from like this. Okay, you tell me, if you want to do offline, then we can do in campus because that needs a lot of preparation as well. Like setting up the camera, securities. You can vote. So if 7 of you want to do offline, we can have at least 7 of you. Then we can have offline and or hybrid. Okay. Yeah, for me, it's more fun if offline because you can do it in the whiteboard rather than in the computer. And we can do games. I've designed several games, but that game can be done only offline, cannot be done in online because you need to move.
Oh, when will the hybrid class start? Is it next week or?
No, optional if you want. That means you need to vote.
Okay, so let's say if majority of us vote yes, then that means
Oh,
we're going to start next week.
We can start next week if you want. No problem.
Oh, okay.
So, Kanis, can you gather the vote? And then-
Yeah, I will send it to the class line group. Sure.
yeah.
Okay.
Yeah. If we cannot do next week, then next week is fine. Yeah. But if the vote is too little, so below 7, then we can still do online like this until end of the semester. Okay. Okay, so Cubic, is there anyone can share the screen? Shall I give you as assignment? That one, the Cubic. If you can share the screen, I will not put it as assignment.
Nggak ngerti deh.
Anyone? So the result will be something like this. Exactly the same as before, but I just add one more column here, which is exponent 3. Okay. Okay, so if you cannot share it, I will just give you as assignment then.
Sir,
Yes. What?
could
You
you
want to share? Okay, cool.
no. I'm just asking in your Excel, where do you put the noise, sir?
The noise I
And
put in the Y. In the Excel, I put the noise in the Y. So here, look at the formula for the Y here.
oh,
Okay, so this is
it's
the
using random.
random inverse. It's Gaussian noise, right? Gaussian noise is norm inverse of random and then mean and variance. Huh? This part here is the Gaussian noise.
Okay, sir.
Okay, inverse of the normal distribution, but because it's noise, so you could put it random. Okay. Okay, so I need to give you the last part. Last part of the regression is actually regression for classification. Yeah. So far the dependent variables of the regression that we have discussed so far is always numeric, right? Never category. Okay? So the question is it possible to use linear regression technique for classification? What is the meaning of classification? Okay. If the Y here, yeah, the output is categorical or nominal or ordinal. Yeah. The answer is yes. Okay. But the result must be assigned to the nearest categorical value. Okay. So, and the number of category, yeah, if the number of category is equal or more than 3, the result may not be correct also, right? So how to do it? The same, exactly the same thing, yeah, using generalized inverse a while ago, okay? But the final result, okay, of the estimation is rounded. So how to round? You get the minimum of the target value, okay, minus the estimation, and then you square it. So here I get the regression for the so I put here between 0 and 1. So because I have 3 category, right? So then I put this line of 0.25 and 0.25 and 0.75. So you see, I have 3 category here. And this is the plot of X1 and X2, and they are correct. Yeah? They are correctly classified. Yeah? The error is rather small. But if the number of cluster increase, okay, the total misclassification become very big. For example, here, in this example here, on the left side, I get a lot of error. Yeah? On the right side, again, this is 4 category of the data. And again, I get a lot of error. Yeah? So you can practice, yeah? also using multiple linear regression. So here we put only two categories. So you put it 0 and 1, right? Then you can actually do regression. This is the how to do it. Exactly the same method, right? The only difference is now the Y is categorical. Okay? Of course, even if categorical, you still need to put it into numbers. So the number is between 0 and 1. Okay. So this is the result you can see. So you will get discriminant, similar to LDA. Later, next time we can discuss about LDA if you want. And we can also do regression in different way. Okay. Using OLS, ordinary least square, what we have is to minimize the sum of square error. Okay. Y is the data, Y cap here is represent the estimate. So, and then you take this into square, and then you sum everything. So S here mean what? S here mean sum square of error, right? SSE. Okay. So the problem with this model, it doesn't work if the line is actually vertical. Right? So to overcome this problem, you can also use what is called orthogonal regression. Yeah? So instead of vertical error, now the error is perpendicular to the fitted line. The important part here is the perpendicular of fitted line. So this is example I also do using Excel. Yeah. If you use only linear regression, you cannot do because it's vertical. But using orthogonal regression, you can. Yeah. How to do it? The same, yeah? Using a generalized inference. Okay. So up to here, is there any question? What did you learn today? Can anyone give a recap? What did you learn today? Anyone?
Using matrix as regression. Matrix with regression. Regression with matrix.
Yes. Why do you use matrix?
Because you can substitute the model with simpler terms. I mean, not only that, but
so the model is the same, right? Meaning A times B equal 1.
yes, same.
But now inside A, you can put any model that you want.
Yeah, right.
Okay. So this is the power of matrix then. And then also the second advantage of using matrix is the size does not really matter, isn't it? Right?
Yeah.
Because different size, even if you have 1 million data, the equation is still the same. And of course, you use Excel, you still need to do it again. But if you use programming language instead of Excel, so you don't need to reprogram. You only do the programming one time. Okay. So that's the advantage of using matrix. Yeah? And you will familiar yourself with matrix. If you are not familiar with matrix, you need to learn again you open again your linear algebra lesson last time that you have taken, right? Because in this course we will use a lot. Yeah? Especially what we need to do is called singular value decomposition. Yeah. So what is SVD or singular value decomposition? Basically, you have a matrix A, okay, and then you will decompose this into 3 matrices. Okay. So let's call this P, times D times Q. Okay, so singular matrix decomposition will create a matrix, three matrices, okay, where the P and Q are orthogonal to each other. Okay, meaning P times Q will be I. Okay, and D here is always diagonal matrix. So this method to decompose one matrix, it is a M by M, meaning this is a rectangular matrix, okay, into three matrix like this. This is called singular value decomposition, SVD. So of course, you can do this in programming language, but not in Excel. Right. So if you still need to use Excel, probably I need to give you the add-ins to do SVD. So next week we will discuss about PCA. So PCA is basically SVD itself. Okay. So please learn before the class so that we can discuss better. Okay. So thank you for coming today, and don't forget to come early next week, okay? Because we will have a test.
Okay.
Yeah.
Okay, sir.
Okay, sir. Wait.
And if you want to share.
Yeah. Yeah. Wait. Oh. Guys, you can see the QR, right?
Okay.
Okay.
Okay, thank you.
Guys.